What we're going to do in example 3, A, B, and C, is we are going to take what they've given us and see if we can simplify it, if we can make it any simpler using our double angle identities. Well, what I noticed right off the bat in this one, I've got cosine squared 7x minus sine squared 7x. That looks a lot like the other half of this double angle identity. I know the cosine of 2a equals cosine squared a minus sine squared a. So this looks a lot like this, where we can see that a is 7x. So if we know what a is, we know a is 7x. We can just take out this a and plug in 7x. Let's write it a little simpler. So we're going to write this as the cosine of 2 times 7x. And that's going to give me the cosine of 14x. And sometimes we like to use parentheses, sometimes we don't. Just looks a little neater. So that's how we do A. Boom. For B, can you find the double angle identity that looks like this? Well, to me, this looks a lot like the sine of 2a. This sine of 2a equals 2 sine a cosine a. And according to what we're looking at, a equals 15. So what we can really do is we're going to find the sine of 2 times 15. So that's going to be the sine of 30. Well, the 30 is on my 30 degrees is on my unit circle. It's the first line up. And this is at the point radical 3 over 2 1/2. Sine, radical 3 over 2 1/2. So, and then the sine of 30 is 1/2. Boom. I had it written down wrong in my notes. I'm going to do this one in class with us when we get together. It'll be great. We'll knock it out, no problem. Let's go ahead and in the same one, let's do example number 4. Example number 4 is just verifying that this is an identity. Verify that the cotangent x sine 2x equals 1 plus cosine 2x is an identity. Alrighty, so working with making identities, I'm going to make all my cotangents and tangents and cosecants and secants. I'm going to make those sines and cosines. So I know the cotangent of x is cosine x over sine x times the sine of 2x, and it's going to equal this side. Hold on, I'm drawing a brain for equals 1 plus, cosine of 2x. Wow, I was just having a moment there. So what I am going to do here, I know normally we all right, sorry, I'm back right here real quick. So what I want to do is I've got this sine 2x. Let's use our double angle identity to write out what that is. So we're going to do the cosine of x over the sine of x. Well, sine of 2x, we're going to sine 2x, we're going to rewrite as 2 sine x cosine x. What I did is I used the double angle identity and I rewrote that as that. So when we multiply these together, what we're going to find out is these sine x's are going to cancel out. And so we're going to be left with 2 cosine squared x, and that equals 1 plus cosine 2x. because cosine x times cosine x is cosine squared x. Boom, boom, boom. So when we've got our 2 cosine squared x equals 1 plus 2x, cosine 2x, I don't really want to work with both sides. So if we do 2 cosine squared x, I do want to bring the 1 over. 2 times cosine squared x. I am going to subtract the 1. I know normally we don't like to, but watch what's going to happen. 2 cosine of 2x. Well, if you look at your double angle identities, 2 cosine squared a minus 1 is cosine 2a. So then we're going to get cosine 2x equals cosine 2x. I have proved that identity. Pretty cool. Pretty cool. Just you can get a little confusing at times, and that's what happened up here when I went radio silent for a minute. I had to figure out, wait, where am I going with this? And it took me a minute to regroup. And sometimes that's going to happen, and that's okay. So if you got any questions, let's come to class and ask them, and I'll be glad to answer them.